Welcome back, students. In last video we discussed about decimal representation of rational numbers. Rational numbers were represented either as terminating or non-terminating decimals, but only non-terminating recurring decimals. Today we will talk about irrational numbers denoted by Q with a bar over it. Rational numbers are denoted by Q and irrational numbers are denoted by Q with a bar over it. What is an irrational number? A non-terminating but a non-recurring. Non-recurring means the digits does not repeat after decimal. A non-terminating, non-recurring decimal is an irrational number. Example 0.424344445. No number is repeating. Every time we are getting different numbers. 3.862045. After decimal, all the numbers are different. So it is a irrational number. This is what is an irrational number. The value of pi is 3.1415. That is, pi is an irrational number. 22/7 pi we take is an irrational number. Next, what are irrational numbers? The square roots, cube roots, etc. of natural numbers are irrational numbers if their exact values cannot be obtained. If they cannot obtain with the, for example, the square roots of numbers which are not perfect squares are irrational numbers. The cube roots of numbers which are not perfect cubes are irrational. Example, root 2. If we solve for root 2 is equal to 1.4142135 and so on. No matter how many times you solved, how many decimal places you take, you will never get the remainder 0 if you are solving by division method. So root 2 is irrational. But root 4 is equal to 2. 4 is a perfect square, so root 4 is rational. If it is a perfect square, it is rational. If it is not a perfect square, it is irrational. Similarly, root 3 is irrational because root 3 is 1.73205080. These are what are irrational numbers. Now, if you are asked to tell, a number is given and you are asked to tell us whether it is rational or irrational, then if it is terminating or non-terminating and recurring, then it is rational. And if it is non-terminating and non-recurring or a number of this form, then it is irrational. If your question is given to you that tell whether a number is rational or irrational, you will judge on this basis. If it is terminating or non-terminating and recurring, it is rational, otherwise it is irrational. Now we'll learn one method of inserting a rational number between two irrational numbers. Two irrational numbers are given to us, root 2 and root 3. And our work is to insert irrational numbers between a rational number between them. Now there are infinitely many rational numbers between root 2 and root 3. Between any two irrational numbers, there are infinite rational numbers. The method you will be following is, I am demonstrating it for one rational number. You can insert many. Root 2 and root 3, and the question is insert one rational number between root 2 and root 3. Now first you do square of root 2 will be equal to root 2 into root 2, that is equal to 2 always. Root 2 into root 2 is always equal to 2. And root 3 square will be equal to root 3 into root 3, that is equal to 3. Squares of these numbers are 2 and 3. What you do is you find any number between 2 and 3 which is a perfect square. Any number between 2 and 3 which is a perfect square. What will be that number? 2 is less than 2.56 less than 3, and 2.56 is a perfect square of which number? 1.6 square is always equal to 2.56. 1.6 square is 2.56. So required rational number will be equal to root 2.56, that is equal to 1.6. One rational number between root 2 and root 3 is 1.6. 6. Square both the irrational numbers and then look for a rational number between them which is a perfect square. Here it is 2.56, which is square of 1.6. Then required number will be square root of that number. You can take many more numbers. With many numbers are present between them which are perfect squares. So you can take any one of those. Next will be square of 1.7. That will be 2.89. So any number you can write. You can get different answers for this question. Next is inserting an irrational number between two irrational numbers. Right now we inserted a rational number between two irrational numbers. Now we will be inserting irrational only. Again, you do square of root 5. There are two numbers, root 5 and root 7, and we have to insert one irrational number between them. Root 5 square will be equal to 5 and root 7 square will be equal to 7. Square of root is always the number that is inside. Now between 5 and 7, you look for a number which is not a perfect square. When we were doing rational, we were looking for a number which was a perfect square. Now when we are learning irrational, we will look for a number which is not a perfect square. So 5 is less than, a number 6 is there in between 5 and 7, and 6 is not a perfect square. 5 is less than 6, less than 7, and 6 is not a perfect square. 6 is not a perfect square. Therefore, root 6 is the required irrational number. Root 6 is the required irrational number between root 5 and root 7. For irrational number, look for a number which is not a perfect square, and for rational number, look for a number which is a perfect square. This is how you insert irrational number. You can insert more numbers between them which are not perfect squares. Next method is for inserting an irrational number between any two rational numbers. We have two rational numbers, 1/3 and 1/2, and we have to insert 1, 2, or we can insert as many because there are infinite irrational numbers between them. So I am demonstrating for 1. You can insert more. First of all, you change 1/3 in decimal form. Write decimal representation for it. You will be dividing 1 by 3. Show this division here. 3 zeros are 0 minus 1. 0 will come here. 3 threes are 9 minus 1. 0 will come here. 3 threes are 9, and so on. It will continue. So 1/3 will be equal to 0.3 with a dot over it, or 0.3333, and so on. Similarly, you will change 1/2 in decimal form. 1/2 in decimal form will be 1 divided by 2. That will be 0.5. So 2 is equal to 0.5. Now 1/3 is equal to 0.333 and so on, and 1/2 is 0.5. We have to insert one irrational number between these. And what was irrational number by definition? Any non-terminating, non-repeating. Means we will insert any number between them which is non-terminating and non-repeating. One rational number between 0.3 and one irrational number between 0.3 and 0.5 is, you can write any number, 0.40, 400, 4000, and so on. Here see, it is non-terminating and the digits are not repeating. Nothing is repeating. First there was 1 0, then 2 zeros, and 3 zeros. All the digits are changing, so it is irrational number. You can get many answers You can insert 4 1, 4 1 4 1 and so on. Any number can be inserted between them, which is irrational, which is non-recurring and non-terminating. There are infinite numbers. Let us see one more. This will be solved with the different method now. 2 and 3. Again, we have to insert one irrational number or 2, 3, 4 irrational numbers between them. Now what we do for it, just square this number. Square of 2 will be equal to 4 and square of 3 is equal to 9. Square of 2 and square of 3 is 9. Now between 4 and 9 we will find any number which is not a perfect square. Between 4 and 9 we have to look for one number which is not a perfect square, which is not square of any number. We have 5, 6, 7, 8. All numbers are between these and all are not perfect squares. 5, 6, 7, 8. This is just for explanation I am writing. None of them is perfect square. No perfect square we are having, so we can choose any number from these. We can choose any number and square root of that number will be the required irrational number between 2 and 3, because we have learned that square root of numbers which are not perfect square is always an irrational number. So we can write 4 is less than 5 less than 9, and because 4 is less than 5 less than 9, we have root 4 is less than root 5 less than root 9. That is, root 4 is 2 is less than root 5 less than root 9 is 3. So one irrational number between 2 and 3 is under root 5. You can write under root 6 also, 7 also, 8 also if more than one are asked. With this we have completed 2 exercises. I hope you will be able to do the questions easily. We'll meet next time with next exercise.